Let's get started. My name is Thomas. I'm the co-founder and CEO of the Zulu GmbH, and this is a company is building an open source CMS. I have about 15 years of experience in web development, and I'm currently in PHP, Symfony, React, also in the front-end stuff, SQL, Redis, and also Elasticsearch. So yeah, that's short about me, not too long. Let's have a look at the agenda for the talk. First of all, I want to also ask you, who knows Redis Streams? Before today? Okay, who is using Redis Streams already in production? So it's going to be a little bit more deep dive into Redis Streams because I really enjoy working with that. More in an architectural way, so it's really about the software architecture and what is bound to Redis Streams to make the services more reliable. And I don't have that big numbers, but that's general the agenda for now. And a short story how I came across Redis Streams. I attended a workshop last year about building autonomous services, like so that the services doesn't depend on each other. And to summarize in one sentence, it's more like tell, don't ask. So that each service knows about everything he needs to work. So it builds up a own read model, and it consumes domain events from a central stream. Central stream could be, as we know already, a Redis stream. But back then I were aware of that Redis is supporting streaming. So it's really about, yeah, you need to look into your tools and have a look at the features, what they're really providing. And I was still searching for, because in this workshop we used this program to fulfill this requirement, maybe not the best solution to run in production. So we added the file and added lines to the file and consumed them. Maybe not really good. So I started to do Googling, and there is a lot of buzzword bingo going around: streams and microservices, CQRS, event sourcing, messaging queues, unified log depend, whatever you're looking for. I think these are all buzzwords we know already. But I want to go a little bit deeper and what is a stream in general? A stream is a sequence of data elements made available over time. That's the definition from the wiki page you can find. And to visualize that a little bit more, because I'm quite a visual person, I've done this. You can have a look at this stream. So we have a stream of records, and we have multiple consumers which are consuming this stream. And there are producers which are adding new records all the time. And the interesting thing is that you can read more than once the message. That's the most the significant difference to a queue. So you can have numbers of reads on the same entry over and over again. And if you're sure you have done the work, you can, for example, truncate some records which are not relevant anymore. So that's the main difference to a queue system. So then I stumbled about Redis Streams, and the unified log was a quite interesting blog post. And there was an eye-opener like, okay, Redis has streams in it. It was about a year ago. So, and I was really into this topic because Redis already provided in the ecosystem of PHP. You often use Redis for session handling, for caching, whatever. So it's like the Swiss Army knife you already have in your environment. So it makes totally sense to use that also for your streaming technology. So Redis Streams got introduced with the 5.0 release. That was in, if I remember correctly, it was October of the last year. It was generally available. And now let's dive into some commands to really grab what are streams and what are they capable of. So I assume you already have some Redis installed, and Bash you could connect to your Redis server. On the right side you find also the PHP example. It may not be that interesting for you, so have a look on the CLI command line tool for Redis. But I'm from the PHP world, and obviously I have these examples with me. So we are connected. Let's add a message to the stream. It's quite simple. You have this xadd command to add a message to a certain stream name. If you use the asterisk for the ID, Redis generates the IDE for you. And the IDE exists of a micro time, milliseconds time, sorry, and a dash and an incremental. So it's guaranteed that it's always in the sequence, that all messages you add to the stream are really in the sequence order that you added them. And you can check with xlang the length of your stream, which are you talking to. Read, you can count reads. You can say I want two records from the stream, and you can read in parallel from also different streams. That's why it's in the PHP version it's the array syntax, and you say a starting point. So from the starting point 0, it's the lowest ID. Obviously, you start from the scratch, from the beginning of the stream, to read all the messages which are recorded in that stream. There is also the option to don't pull all the time and avoid pulling. You can read blocks, so blocking read. And the interesting thing is there is a dollar sign, so that you start with a 0, and the dollar sign indicates that you want to receive only new messages. So handling in general the messages where you're consuming is up to your application. So you need to know at a certain point when you start and you break down, the service went down or something is broken, you need to recover the service, and you need to remember where you start from the stream and try to process the new messages again. So normally you start with a 0, keep the track of your record ID, and then move on. So that's quite nice, but it's all to keep in mind. All clients are receiving all messages in the stream, and how to scale now a certain operation I need to scale over the stream, so that not only one client is reading that information, but multiple clients are reading the same record from the stream, and there comes in the consumer group. Another visualization for the consumer group, you can think of like consumers joined together in a group, and then Redis is able to kind of distribute all the incoming messages, or at least he knows exactly on which record each consumer is reading currently, and is kind of load balancing, distributing, sharding all the records among your clients, among your consumers. So you have the possibility to have multiple groups, and in the group you have the possibility to have multiple consumers. That makes it scalable, so that you have really the possibility to things that take long to add more consumers within the same group, and more clients can do the work, and more clients are able to read the message. So how do we do that? So we need to create a consumer group. We need to create the consumer group by a stream name and a group. Then we can read from that consumer group. With all the information you need to know which is the group, which is my consumer name, and what's the stream name. Again, 0 in this case is a little bit different. In this case, 0 indicates that you want the last message you as consumer already consumed but wasn't able to acknowledge. That's something I will explain a little bit later. And with the greater than sign, you get all the messages which are not has been delivered till now. So that when you kind of add a new consumer to your group, you can start with the 0, check if went something wrong. Maybe I broke, I went down. And when there is no message, you go on and read with the greater sign to get new messages in your new consumer client. As I mentioned, you need to acknowledge now messages, so that Redis is aware of, yes, this message now was delivered already, I've consumed it, but it's also important that Redis knows that you have fulfilled your job and the message was processed successfully. That's quite important. So now all this kind of knowing which position I am, where I need to restart, or where I need to know what was the last message I've already consumed and worked, is now done by Redis. That's quite a neat feature. And it's also about failure processing. So if there's really a job or a record in the stream which nobody is able to fulfill the process, and it's not able the pending client already claimed the message and is not able to consume anymore. So Redis knows a lot about the certain message, so he knows how often a consumer has retried to get the message. He knows when he got the last information about the message, and so you can look at all these pending messages and reclaim them for another consumer. That's quite powerful if really a consumer goes down and is not able to fulfill his job anymore. So that was about really the basic commands and Redis interface, but in our case, it worked really great, and we tried a lot of things, but I needed like more high-level abstraction for my developers. And I'm, as I mentioned already, in the PHP universe, maybe not the cool kids on the block do PHP anymore, but still a lot of people are developing PHP, and we use Symfony. So Symfony is our framework for everything we do, and the Symfony has a nice messaging component. So the messaging component is quite powerful within this architecture of PHP. You are able to send and receive messages like on a message bus, and you are able to, normally messages are kind of handled immediately, so synchronously, but you can configure transport layers into this message queue and route messages so that you can do asynchronous jobs and work as well. By default, at that state, Symfony only supports RabbitMQ, and it was the time where Symfony Messenger 4.2 was available. So yes, why not implementing our own transport layer? So we started to implement our own transport layer, which directly uses Redis streams to do all this messaging stuff and all this handling of concurrency, of dispatching messages to all the consumers and to the different consumer groups. That worked out really good. We used it for a project where we had some legacy code base and needed to get information from a new code base back into the legacy code base. And so that was quite a good experience to like a proof of concept. And in the meantime, it was quite interesting that somebody started the Redis transport layer already. And this was based on a list and had this, because it was important for the messaging component that he knows when a message was acted, so it was really processed. And so we hooked in and said it was quite complex, so moving one item from a list to another Redis list and have a processed list, and it was quite difficult to when you looked at the code, so it was quite complex. And so we captured this pull request and said, hey, have a look at our implementation. Maybe it makes sense to bring that back to the Symfony community. The initial statement was, oh, that looks like a little bit confusing. Why we need these Redis streams overhead, it's complex. And then we jumped in and explained it a little bit more and say, yeah, keep that in mind. That's all the things you're doing now manually, moving items from one list to another and having that trouble of distributed stuff and like parking messages somewhere, that's done by Redis. So why not leveraging this feature? And finally, yes, they closed the old pull request and we contributed the Redis stream transport in the Symfony environment, and now you are able to use Redis transport in the Symfony 4.3 release. So again, open source for the win. I really enjoy that. I mean, you can give something back to a community. So I've explained some basic about Redis streams, how we kind of put that back in the open source world. Now some real world showcase we did. Quite interesting about today was a lot about ticketing and selling tickets. And we had the same issue. It's obviously not about the big numbers, it's more like the concept of architecture. So we had this monolith, so I'm not going to explain it exactly like a microservice service. So we had a monolith with bounded contexts. Bounded contexts is like from the DDD approach, so that you don't have relation between these bounded contexts, and they need to be separate quite clean. So that was our approach on like the service-oriented architecture. So we had this like services in a monolith, but they were not allowed to have direct connection to each other. And quite interesting, we did a lot of these bounded contexts to fulfill all this ticketing, from managing the show, managing the tickets, the orders. And the only thing which was a third-party application was the access control. So at the access control, there was someone with the phone scanning the barcode. And that was a separate system, so we needed to synchronize also to this third-party application, so that this was aware of our state of our tickets. So in general, we regenerated all the tickets when a show got live, so for selling, and then we generated all the ticket codes and initially synced them to the access system. But for example, if you go to the box office in the evening, you buy a ticket and go 2 meters to the access system need to know that the ticket is now valid and it's sold, and not in a unsold state. It's still valid, but unsold, for example. And it was quite challenging because the REST API wasn't that stable, so we needed to retry stuff, but we didn't have a big time frame to get this done. So that was quite powerful to have this Redis stream quite deep in our architecture. So the architecture looks like this. We have the message bus is our central communication. Every bounded context is publishing domain events on this message bus. So domain events, we will have a look how we use them. And for example, if a ticket was sold, the order dispatched ticket was sold, the access in our system, the access bounded context received this message and called the external system and retries against, but still it's not blocking, the sell was already done. So it was asynchronously in this way. So again, it's about tell, don't ask. So it's about telling what's happening in your system, recording these domain events which trigger state changes in your application, and don't ask any service all the time, which is your state, what's wrong with you, what is your state, what's going on in your site. So it's really about emphasizing this concept of tell, don't ask. So let's have a look at code. Our domain event message was one central message which was standardized that had a name, has a type, had an ID, and had a generic payload and a date time when it was created. So on every place where something happened in our code base, for example, a ticket was cancelled. When a ticket will be cancelled, so somebody is cancelling the ticket, you immediately need to invalidate the current ticket code, and you normally need to regenerate a new ticket code because we have a certain amount of tickets and we need to sell them. So this is the things we need to do. So a ticket was cancelled. The workflow engine is really checking if it's possible to cancel the ticket. Then we create a new ticket, and in the last step we have this domain collector, which is done at the last state of if everything was committed, all domain events were also published. So only if this cancel action is really going through our systems, through our transactions, at the end our domain events got published. So we record our domain events, and the last information we do is like publishing this event which were happening while this request. And then in the access code base, we had a listener, so a consumer from the Redis stream, which is checking on the type and also on the name of the object. So we had full qualified name for the objects we are manipulating in our domain. And if it was not cancelled and it was not ticketed, it isn't interesting for us. So let's move on. But if it was a ticket and it was cancelled, we need to act. So we need to cancel a ticket in the access system. So we need to trigger that change, and we need to add a new ticket which was created hopefully while the other ticket was created. So it's a clean separation, like The access system was really independent from all the stuff like ordering and ticketing and whatever it is, and it always came down to listen to events on the stream of the records, identifying if the record is relevant for you, and then act on that. So the last thing is we didn't use Redis for long-term storage. So from time to time we needed to trim all the information we didn't need anymore, because else Redis gets a lot and consumes a lot of memory. And the interesting thing is here, it was quite important for us that we don't lose this information. So these are all domain events which are quite relevant if you have, for example, starting a transaction for payment and it takes 20 minutes until he came back. Nobody knows what's doing 20 minutes while you're entering your credit card, but we had these issues and we were able to rebuild this setup. So, for example, we increased the time where we're blocking the tickets because we had a lot of people took a long time to fulfill this last payment step. That was something we encountered while analyzing the data afterwards. And it was quite easy. We added another listener, another consumer to the stream, and this consumer stores the message in Elasticsearch. So we have Elasticsearch for kind of all the long-term analysis and things we need to do not immediately, and the Redis stream is our backbone for our service-oriented, domain-driven architecture. Thank you.